The geological history of our planet holds the traces of multiple dramatic shifts in climate and biodiversity. Over millions of years, Earth's climate has swung between extremes, warming periods that encouraged the flourishing of life and devastating cool spells that decimated ecosystems. These oscillations in temperature, solar radiation levels, and atmospheric composition shape the trajectory of life on Earth, turning some evolutionary paths into dead ends and enabling others to thrive. At least 5 mass extinction events are recorded in the last 500 million years, each one eliminating up to 90% of all life forms. Today, scientists warn that we are living through what may be the 6th such event, and this one is unfolding faster than any before. This crisis doesn't stem from a single asteroid impact or volcanic eruption. It is complex, progressive, and global. To understand how we reach this critical point and what might lie ahead, we must look back, way back, and trace the climatic and biological transformations that have shaped our world since the age of the dinosaurs came to an end. Roughly 66 million years ago, a colossal asteroid, nearly 10 kilometers in diameter, pierced Earth's atmosphere and slammed into what is now the Yucatan Peninsula. The resulting explosion was equivalent to the detonation of millions of thermonuclear bombs, triggering a series of catastrophic events that reshaped the planet's climate and life forms. The impact released tremendous energy, sending shockwaves across the globe and launching massive quantities of rock and debris into the atmosphere and beyond. As molten material rained down over vast distances, it ignited wildfires, stirred massive earthquakes, and generated tsunamis that ravaged coastlines and surged deep inland. 15 trillion tons of soot and dust rose into the skies, forming a blanket that blocked sunlight for years. The planet plunged into a deep freeze. The average global temperature dropped to just 3 degrees for more than a decade. This climate collapse led to widespread famine as plants died off, causing a ripple effect through the food chain. Most animals heavier than 25 kilograms, including all non-avian dinosaurs, vanished. What followed was not just destruction, but also rebirth. The dawn of the Cenozoic era, when mammals and flowering plants began to dominate a drastically changed world. This marked the beginning of a new era, a time when life, against all odds, began again. Just like Earth rebuilt itself after unimaginable loss, this channel is also growing, step by step. Our next milestone is reaching 1,000 subscribers by June 30th. And every single person who joins makes a real difference. If you're enjoying the journey through time and reflection, consider subscribing. It means a lot. The first 10 million years after the asteroid impact, known as the Paleocene epoch, were marked by a gradual healing of the Earth's wounded biosphere. Volcanic ash slowly settled, skies cleared, and global temperatures began to rise, creating a more hospitable environment. New species began to repopulate the planet, but the life forms that emerged were dramatically different from those that had existed before. With the dinosaurs gone, ecological niches opened up, allowing mammals to flourish and evolve. Small marsupials, once hidden in the shadows of towering reptiles, started to diversify and expand. Flowering plants spread across continents, and birds, descendants of avian dinosaurs, soared through the recovering skies. This resurgence of life was accompanied by an increasing trend in global temperatures, peaking during the transition into the Eocene epoch about 56 million years ago. At that time, tectonic activity and intense volcanic eruptions released massive amounts of methane and carbon dioxide into the atmosphere, pushing greenhouse gas concentrations to more than 2,000 parts per million, a staggering figure 5 times higher than today's levels. Earth transformed into a greenhouse world, setting the stage for another significant phase in its climatic evolution. During the Eocene, which lasted approximately 22 million years, the planet experienced some of the warmest global temperatures in its history. Average temperatures occasionally soared to 28 degrees C, and the entire Earth, even the polar regions, was cloaked in lush vegetation. Palm trees and tropical reptiles thrived in what is now Europe, and dense, broad-leaved forests extended into the Arctic Circle. These balmy conditions were largely driven by the layout of the continents, which at the time allowed oceanic and atmospheric currents to circulate heat more evenly around the globe. North and South America were separated by a broad oceanic passage, and Africa had yet to collide with Eurasia, which left equatorial currents unobstructed. Furthermore, the decomposition of organic matter sustained high levels of CO2 in the atmosphere. With abundant food and a temperate climate, mammals experienced a period of remarkable expansion. Tiny tree-dwelling species evolved into massive herbivores and carnivores, and the ancestors of modern primates, rodents, and hoofed animals emerged. But even in this vibrant world, subtle shifts were underway. A slow decline in CO2 levels, triggered by the spread of aquatic ferns like azolla in the northern oceans, hinted at an eventual cooling, a change that would alter the course of Earth's climate once again. Around 34 to 35 million years ago, the planet underwent a sharp and unexpected climatic shift, marking the end of the Eocene and the beginning of the Oligocene epoch. This transition was triggered by a combination of major geological and biological events. The collision of tectonic plates gave rise to vast mountain ranges like the Himalayas, the Alps, the Carpathians, and the Appalachians. These towering formations altered wind patterns and atmospheric circulation, significantly impacting global temperatures. Simultaneously, a new type of photosynthesis, C4, began spreading among plant life. This process proved far more efficient than the previous model, gradually increasing the oxygen concentration in the atmosphere by up to 2 to 3%, while drastically reducing CO2 levels. The reduction in greenhouse gases weakened the planet's natural heat retention, contributing to global cooling. Additionally, tectonic movements severed the land bridge between South America and Antarctica, forming the Antarctic Circumpolar Current, a cold, isolated oceanic ring that encircled the southern continent. This, combined with a powerful atmospheric jet stream, effectively insulated Antarctica from warmer air masses. As a result, the continent's temperatures plunged, and its once forested terrain was rapidly overtaken by expanding glaciers. This dramatic drop in temperature marked the start of the Oligocene epoch, which lasted for about 11 million years. During this period, the planet's climate stabilized into a pattern that was cooler and drier than before, yet still noticeably warmer than present-day conditions. The cooling trend persisted into the Miocene epoch, but it was around 14 million years ago that the Earth experienced another major climatic downturn known as the mid-Miocene extinction event. Scientists believe this episode resulted from two key factors. First, the Earth's orbit once again aligned with the colder phase of the Milankovitch cycles, natural fluctuations in Earth's position and tilt that affect solar radiation levels. Specifically, when Earth's orbital eccentricity is high and the winter solstice coincides with perihelion, the planet receives less solar energy, leading to cooler conditions. This alignment occurred during the mid-Miocene, prompting the expansion of grasslands and the retreat of forests. The second factor was the continued success of C4 plants, which thrived in the open, sunlit environments and further lowered atmospheric CO2. These combined processes reinforced the cooling, setting in motion a powerful feedback loop that would continue shaping Earth's future for millions of years to come. To fully grasp the environmental changes during the Miocene, it's essential to understand the role of the savannas and other similar biomes that emerged during this time. These ecosystems, rich in biodiversity, were incredibly productive. A single square kilometer of savanna could generate up to 1,500 tons of biomass annually, rivaling even the densest forests. The nutrient cycle within these environments was swift and efficient. Short-lived grasses provided abundant nourishment for herbivores, while their rapid turnover ensured a continuous release and absorption of elements like carbon. As the extent of savannas increased across the planet, CO2 levels dropped further, which in turn deepened the global cooling trend. Over several million years, Earth's average temperature declined from approximately 17 degrees to 11 degrees. This dramatic drop significantly impacted the fauna that had thrived in warmer conditions. Much of the megafauna from earlier epochs disappeared, unable to adapt to the harsher, cooler climates. Among the notable survivors of this transformative period were the proboscideans, ancestors of modern elephants, and ancient horse species known as hipparians. Apex predators also adapted, with bear dogs and hyena-like creatures emerging, some of them weighing nearly half a ton and dominating their ecosystems with brute strength. The gradual cooling trend that began in the Miocene continued inexorably into the late Neogene period. Around 8 million years ago, the Earth witnessed a significant expansion of glaciers in subpolar regions. Antarctica's ice sheets thickened and spread, and a permanent polar ice cap began forming in the Arctic Ocean. Greenland, once covered by thriving forests, began transforming into a landscape dominated by ice. Yet the planet was still approaching one of its most defining geological moments. Approximately 2.6 million years ago, temperatures dropped even more sharply, initiating the Pleistocene epoch, the most recent and perhaps most climatically turbulent phase in Earth's history. Several tectonic and oceanographic developments contributed to this shift. The formation of the Isthmus of Panama, which connected North and South America, disrupted ocean currents by blocking the flow between the Pacific and Atlantic Oceans. Warm equatorial waters could no longer circulate freely, causing the Atlantic to cool substantially. Simultaneously, the rising Rocky Mountains further hindered the movement of warm air masses across the continents. These changes increased seasonal temperature variations and accelerated the formation of massive glaciers. The Earth was entering a new age of ice and survival, a time that would test every species, including our earliest ancestors. As the Pleistocene epoch began, Earth entered a cyclical pattern of glaciations, long ice ages, punctuated by shorter interglacial warm periods. Glaciers advanced and retreated over tens of thousands of years, sometimes covering up to 30% of the planet's land surface. These cycles occurred with remarkable regularity every 41,000 years, closely tied to variations in Earth's orbit and axial tilt, known as Milankovitch cycles. The movement of ice sheets reshaped entire landscapes and transformed ecosystems. Vast ice masses carved out valleys, altered river paths, and created new lakes. In response to the harsher climate, species adapted dramatically. Herbivores developed thicker coats and bulkier bodies to retain heat, giving rise to iconic megafauna like mammoths, mastodons, and woolly rhinoceroses. Predators evolved alongside them, becoming larger and more robust. In North America, giant short-faced bears roamed, potentially weighing up to 200 kilograms, 3 to 4 times the size of today's polar bears. Just south of their range, dire wolves hunted in coordinated packs, nearly twice the size of modern wolves. These powerful predators likely worked together to bring down massive prey like bison. Life during the Pleistocene was a constant contest between adaptation and extinction, one shaped by the whims of a volatile climate. Around 1 million years ago, the glacial rhythm changed dramatically. Previously, regular 41,000-year cycles gave way to longer, more irregular intervals averaging 100,000 years, each ice age becoming deeper and more intense. This shift called the mid-Pleistocene transition, remains partially unexplained, though researchers believe several contributing factors played a role. One leading theory suggests that earlier glaciers eroded the regolith, the loose sediment covering bedrock in northern latitudes. As glaciers began forming directly on more resistant surfaces like granite and basalt, their expansion became slower and more stable, resulting in longer cold periods. Another contributing event was the closure of the Bering Strait approximately 900,000 years ago. A drop in sea levels exposed a land bridge between Asia and North America, halting the flow of cold Pacific waters into the Arctic Ocean. This further cooled the planet, intensifying glaciation. Meanwhile, early human ancestors continued their global migrations. Fossil records show they spread across continents in waves, adapting to new climates, competing for territory, and forming distinct cultures. Some groups vanished without a trace, while others endured. Those who survived through the extremes of ice and isolation would eventually give rise to modern humans, the inheritors of an Earth constantly reshaped by fire and frost. Just as early humans began to leave their mark on the world, our small actions today carry weight. If this story is sparking something in you, curiosity, awareness, or even concern, don't forget to like this video and follow the channel. It helps this message reach others who, like you, are seeking to understand our place in Earth's story. The final chapter of the Pleistocene epoch, known as the Tertian Age, began approximately 129,000 years ago and extended for nearly 117,000 years. It was a time defined by intense glacial activity and extreme environmental challenges. During this period, anatomically modern humans, Homo sapiens, emerged and began expanding beyond Africa and Eurasia. In their relentless pursuit of survival, these early humans ventured into uncharted lands, crossing the Bering Land bridge into North America during phases of low sea levels. They became the ancestors of numerous indigenous tribes across the Americas. Simultaneously, another group journeyed toward the Pacific, eventually reaching the shores of Australia. Around 50,000 years ago, humans set foot on this isolated continent, encountering a land teeming with giant marsupials and unaccustomed prey. Without predators adapted to human hunting strategies, species like the Diprotodon and Palorchestes were rapidly hunted to extinction. The settlers also began setting deliberate fires to flush out animals, sparking massive forest blazes. Within a few millennia, most creatures over 45 kilograms vanished. In the wake of these fires, lush forests gave way to barren semi-deserts, covered with sparse grasses and tough shrubs. Australia's arid climate and poor soil ensured that these forests would never recover, a permanent scar left by humanity's earliest environmental impact. When sea levels rose again, the people of Australia found themselves geographically trapped on a scorched continent with limited resources. The once abundant food supply dwindled and the population stabilized only after enduring bloody conflicts and prolonged famines. Without surplus resources or favorable conditions, these early societies faced enormous challenges in developing the kinds of advancements seen elsewhere. For many, the door to civilization remained closed. Meanwhile, the broader planet was undergoing a transformation. Around 11,700 years ago, the last great ice age came to an end, marking the conclusion of the Pleistocene and the dawn of a new epoch, the Holocene. Glaciers retreated, ocean levels rose by over 35 meters, and vast regions previously locked in ice became habitable again. Fertile biomes emerged in places like the Nile Valley and Mesopotamia, cradles of human civilization. With ample food sources and predictable climates, ancient tribes began settling permanently. Sedentary foraging gradually evolved into agriculture. This fundamental shift demanded new skills, storing food, building shelters, crafting tools. These innovations spurred the birth of complex societies. Over generations, Pottery, metalwork, and organized governance followed. Civilization was no longer just a possibility, it was inevitable. As civilizations grew and multiplied during the Holocene, so did humanity's influence on the environment. Early agricultural practices, such as deforestation for crop fields and irrigation systems for expanding settlements, began to alter natural ecosystems. At first, these changes were gradual and localized, but as urban centers developed and populations surged, the pressure on the land increased significantly. Cities became hubs of industrial and cultural activity, while the surrounding landscapes were transformed to sustain them. Wetlands were drained, forests were cut down, and rivers were redirected. While these actions provided food, shelter, and economic power, they also began a long, slow process of environmental degradation. Over time, air and water quality declined, natural habitats shrank, and many species were driven to extinction or isolated in increasingly fragmented ecosystems. Still, for centuries, the scale of humanity's impact remained limited. It took generations for noticeable damage to accumulate. That began to change drastically in the 18th century with the onset of the Industrial Revolution. The widespread adoption of coal-powered machinery and mass production fundamentally altered the relationship between humanity and nature. It wasn't just agriculture shaping the land anymore. It was smoke, steel, and steam reshaping the earth itself. The Industrial Revolution unleashed a wave of transformation across the globe. Factories multiplied, cities expanded, and human populations exploded. But the most profound change was invisible, a silent, relentless surge of carbon dioxide and other pollutants into the atmosphere. The combustion of fossil fuels released not only CO2, but also sulfur oxides and nitrogen compounds, which mixed with water vapor to form acidic precipitation. These substances seeped into the soil and waterways, gradually rendering them toxic for many forms of life. The situation worsened in the second half of the 20th century. An era of technological boom brought with it widespread car ownership, air travel, and the global spread of industrial agriculture. On average, a single car emits about 15 kilograms of CO2 per day, roughly 5.5 tons annually. Multiply that by over 1 billion vehicles and hundreds of millions of trucks, and the environmental toll becomes staggering. In 2022 alone, human activity released around 38 billion tons of carbon dioxide. For comparison, volcanic activity, often cited to downplay human emissions, contributes only about 260 million tons per year. Humanity now emits more carbon in a single week than all the world's volcanoes do in a year. The consequences are becoming increasingly difficult to ignore. The concentration of CO2 in the atmosphere has now surpassed 400 parts per million. A figure roughly 35% higher than at any other point in human history. The last time the Earth experienced a similar concentration of greenhouse gases was approximately 5 million years ago, long before the advent of modern humans and even prior to the Great Ice Ages. What makes today's situation particularly alarming is the speed of change. This dramatic rise in atmospheric CO2 has occurred in less than a century, a blink in geological time. The repercussions are already visible. Glaciers around the world are retreating at unprecedented rates. In Greenland, for example, the Jakobshavn Glacier, one of the fastest-moving ice streams, has increased its melting rate fourfold since the beginning of the 20th century. Its front edge now retreats between 3 to 7 kilometers inland each year. Although the pace has temporarily slowed in recent seasons, experts agree that this is merely a pause, not a reversal. Meanwhile, the thawing of permafrost in northern latitudes is destabilizing infrastructure, displacing communities, and releasing methane and carbon from once frozen organic matter. This creates a vicious cycle. Warming causes thawing, which releases more greenhouse gases, leading to even more warming. If Earth's polar ice caps were to fully melt, the implications would be catastrophic. Sea levels could rise by an estimated 66 meters, enough to submerge entire cities and displace hundreds of millions of people. Major metropolitan areas like New York, London, Shanghai, and St. Petersburg would be completely or partially underwater. Entire countries, such as the Netherlands and countless island nations like those in Polynesia, would vanish beneath the ocean. Fertile coastal plains, home to billions and crucial to global food production, would be lost forever. At the same time, rising temperatures are intensifying droughts, expanding deserts, and increasing the frequency and severity of wildfires. Ecosystems are collapsing under the strain. The planet is rapidly approaching, or perhaps has already entered, its sixth mass extinction. Over the last 5 centuries, approximately 1,000 large animal species have gone extinct. Today, more than 35,000 species of vertebrates, insects, and vascular plants face imminent extinction. This includes 40% of all amphibians and 25% of all mammal species. Among them are species vital to human survival, such as honeybees and food crops like bananas. Their disappearance could trigger ripple effects that transform and destabilize life as we know it. Modern humans often regard themselves as enlightened and technologically advanced, but our behavior frequently reveals a dangerous short-sightedness. In our pursuit of wealth, convenience, and power, we've pushed natural systems to their limits, and sometimes beyond. Throughout history, environmental disasters have been fueled not just by ignorance, but by arrogance. We assume nature is limitless, resilient, and forever at our service. But like the early humans who set fire to Australia's forests and hunted its giants to extinction, we are once again behaving as if there are no long-term consequences. We continue to extract resources without restraint, emit pollutants without pause, and ignore the warning signs flashing all around us. Entire ecosystems have been disrupted, and yet we persist in believing we can dominate nature without consequence. If we fail to learn from the past, if we continue on this path of destruction, the collapse of our civilization will not come with a bang, but with a slow unraveling. And it won't be caused by an asteroid or volcanic winter, but by the steady hand of our own indifference. We may not get a second chance. This is the defining moment of our time, and how we respond will determine the legacy we leave behind. Yet, even in the face of this crisis, hope remains, not in ignorance or denial, but in awareness and action. Throughout history, humans have shown a remarkable ability to adapt, to survive, and to overcome. We've transformed barren lands into thriving cities, discovered cures for once deadly diseases, and sent machines beyond the limits of our solar system. The same intelligence and creativity that built our modern world can be harnessed to save it. Sustainable technologies are emerging faster than ever. Clean energy, carbon capture systems, regenerative agriculture, and circular economies offer real solutions. Movements led by scientists, young activists, and local communities are forcing governments and corporations to rethink priorities. These efforts show that change is possible, and that it starts with individual responsibility. Each choice we make, from what we consume to how we vote, shapes the future. We are not powerless, we are participants. And while the damage we've done is undeniable, so is our capacity for repair. The road ahead is steep, but not closed. If we act with courage, wisdom, and urgency, we can still choose a future worth inheriting, not just for ourselves, but for every life that shares this fragile planet with us. The climate crisis is not a distant threat. It is happening here, now, and it touches every aspect of our lives. From the rising cost of food to the increase in extreme weather events, we are already living with its consequences. But it is also a mirror reflecting back to us the choices we've made as a species. It forces us to confront uncomfortable truths, that progress without purpose is hollow, that growth without limits is unsustainable, and that our place on this planet is not one of dominance, but of stewardship. The Earth does not need us. It has endured cataclysms far worse than our emissions. But we need the Earth. Its stability, its resources, and its ecosystems are the foundation of everything we depend on. This understanding should humble us, but also empower us. We have the tools, the knowledge, and the urgency required to act. What we lack, and must urgently cultivate, is the will. We are not simply passive observers of Earth's decline. We are the authors of its next chapter, and in that truth lies both a burden and an opportunity unlike any humanity has faced before. This story, like Earth's climate itself, is one of cycles, of devastation followed by rebirth, of decline countered by resilience. History shows that even in the darkest moments, life adapts, evolves, and finds a way forward. And now, in this defining moment, it is our turn. We must become the generation that refused to surrender to apathy, the ones who saw the fire on the horizon and decided to build a future anyway. Our legacy can be one of recklessness or one of redemption. We stand at a crossroads where science, ethics, and courage must converge. The decisions we make today, in our homes, our communities, and our institutions, will ripple across centuries. Let this not be the era remembered for how we lost control, but for how we reclaimed it. Let it be known that when the Earth cried out, we listened. When the skies darkened, we lit a path. And when the ice melted beneath our feet, we chose not to sink, but to rise. The future is still ours to shape, and if we dare to believe in the power of our collective will, there is nothing stopping us from turning this crisis into a new beginning. Now it's your turn to shape this dialogue. What part of this journey impacted you the most? What do you believe we, as individuals or as a society, should do next? Leave a comment below, and let's build a space where questions lead to action and stories lead to change. Your voice is part of this narrative too.